Hello everybody, welcome into another lesson. So today we are going to put the use of square roots and radicals to work in a geometric application, which I'm sure most if not all of you are familiar with by now, called Pythagorean Theorem. Pythagorean Theorem states that you have one side A plus one side B. The A and B sides, those are called the legs. In fact, let me write that on here, okay? A is a leg, B is a leg, and then C is the hypotenuse, which is the longest side of a right triangle. So, the hypotenuse is always directly across from the right angle. That's the longest side of the triangle. Now, the Pythagorean theorem states that if you take a squared plus b squared, you'll get c squared. And then you can use square roots to solve for the missing sides. So, I know today may seem a bit like a review, but it's worth bringing up because this will come up again in geometry. Big time. In fact, we'll have the converse of the Pythagorean theorem and all that coming up. So, best to do this now because geometry is not terribly far away. Okay, let's start with our first problem here. We have a length of 10, we have a length of 24, but we don't know c, which is the hypotenuse. So, we know we have 10, we can call that our a length, so we'll do 10 squared plus 24 squared, which is our b length. So you'll take each of the sides to the second power, add them together, you'll set that equal to the third side squared, which would be c squared. So far we have 10 squared plus 24 squared equals c squared. Now, let's do the math here. 10 squared, well that's 100. Plus 24 squared, I have no idea what that is off the top of my head, so I'm going to have to get the calculator. Let's see here. 24 to the second power is 576. That's going to be equal to c squared. So in other words, c squared equals actually 676, because when you add 576 and 100, you get 676. So now we just got to find the square root of 676. Which happens to be 26. So the length of side C is going to be 26. And I know you've seen it before that when you take a square root with a variable, it's usually plus or minus the right-hand side, but in this case it's only a plus length. You can't have a negative length. That just isn't going to work. You can't have a negative length. So you only take the positive square root when you use Pythagorean theorem. So the length of side C is equal to 26. All right, what do we got next here? See, side A has a length of 5, side B has a length of 12, and then we don't know C. So, what we're going to do, take 5 squared plus our 12 squared, we'll set that equal to c squared. Alright, well 5 squared, that's 25. Plus 12 squared, that's 144. That's going to be equal to c squared, which c squared would equal 169 when you add those two together. Square root of 169 is 13. So the length of side C, the hypotenuse, would equal 13. All right, next problem. Let's see, we have 5, 8, and then C. All right, so we got triangles here with, we have a triangle with a length 5, 8, and then the hypotenuse. So we'll take 5 squared plus 8 squared. That's going to equal C squared. Well, 5 squared, that's 25, plus 8 squared, that's 64. That's going to equal C squared, which that means C squared would equal 89. Now we got to find the square root of 89. The thing is, I don't think 89 breaks down any further. 89's definitely not a perfect square, and there's really no factors of 89 besides 1 and 89, so the answer for the length of side C is it's simply going to be the square root of 89. And it is perfectly permissible to have answers like that where you get a square root for an answer. So side C will be the square root of 89 for its length. All right, next. C9, 13, and C. Okay. So we have another right triangle here, which Pythagorean Theorem only works in right triangles, by the way. It does not work with other types. But we'll get more into that as we get into geometry. But just know Pythagorean Theorem only works in right triangles. So we'll take 9 squared plus 13 squared, and then we'll set that equal to C squared. Well, 9 squared, that's 81, plus 13 squared, that's 169. That would equal C squared. Well, alright, so C squared is going to equal, that would be 250. Which means C would equal the square root of 250, but we know we can break this down further. That would be equal to the square root of 25 times the square root of 10. So C, therefore, square root of 25 is 5. You would get 5 times the square root of 10. And that would be your answer. You would end up getting 5 times the square root of 10 for side C. So this is where simplifying radicals has come in handy. We've just put it into use here with Pythagorean Theorem. All right. Okay, this time we have side A equals 8, side B equals 8, but we don't know side C. Well, still the same process. You have two sides of the same length. So let's see, you're going to have 8 squared plus 8 squared equal to C squared. Well, 8 squared, that's 64, plus 8 squared, that's another 64. That would equal C squared. So then C squared would equal 128. which means c equals the square root of 128, but 128 is not a perfect square. But we can break it down into the square root of 64 times the square root of 2. Well, the square root of 64, that's 8, and then we just have times the square root of 2. So c, the hypotenuse, has a length of 8 times the square root of 2. That would be the length of side c. In fact, once we get to geometry, we're going to get further into right triangles. This would be a special type of right triangle called a 45-45-90 right triangle, where you have two 45-degree angles and a 90-degree angle. And the two sides across from the 45-degree angles have the exact same length, and the hypotenuse is the square root of 2 times one of the legs. But we did the long way of solving it. In geometry, you'll learn some shortcuts, and you don't have to remember 45-45-90 today. I'm just giving you a preview of geometry. But that'll also heavily be used in trigonometry and pre-calculus and so on. So there's a lot of stuff to cover once we get to geometry. Alright. Now here's where we hit a snag. We don't know side A this time. We know side B is 21. Side C is 29. So we have a little bit of a reversey situation here. We don't have a clue what side A is, but we know side B is 21, side C, the hypotenuse, is 29. Well, it's still the same process, okay? You're going to take your A squared, so just take your A squared plus your 21 squared. You'll set that equal to your C squared, which would be 29 squared. Well, now let's break out the calculator and do a bit of math here. I need to figure out what is 21 to the second power. That's 441. So I would end up getting A squared plus 441 would be equal to, now we need to figure out what 29 squared is. (29 to the second power), that's 841. Alright, so then we want to just solve for A squared. You subtract 441 from both sides, you would just simply get 400. So A squared would be 400, which means A would be the square root of 400, which would be 20. So the length of side A is going to end up being 20. So you can use Pythagorean Theorem to not only solve for the hypotenuse, but for any of the missing sides as well. All right. Let's see here. I only have a few more. This should be a relatively short lesson today. I got like 3 more. Again, we don't know side A. Side B is 11. Side C is 17. So side A we don't know. Side B is 11. Side C is 17. Again, same process. So we're going to take A squared plus 11 squared, set that equal to 17 squared. Well, then we'll have A squared plus 121. I think 17 squared's 289. Don't quote me on that yet. I'm pretty sure it is, though. I was right, 289. So we have A squared plus 121 equals 289, which means now we want to get A squared by itself, subtract 121 from both sides, you'll end up getting 168. So a squared is equal to 168. Alright, so then, let me see something here. I'm trying to see how I can break this down. Alright, so that means a would equal the square root of 168. Well, 168 is not a perfect square, is it? That's okay. We will break this down into the square root of 4 times the square root of 42. Well, we know the square root of 4 is 2, but the square root of 42 does not break down any further. So what you'll end up getting here is you'll get 2 times the square root of 42 for your answer. So the length of side A has a length of 2 times the square root of 42. Then I just have 2 more problems and we're done. Alright. This time we know side A is 6. We don't know side B. But we know side C is 40. Okay, so we have a triangle, right triangle with length 6, B, and 40. Well, still the same process. You'll take your 6 squared plus B squared. You'll set that equal to your 40 squared. Well, 6 squared, that's 36, plus your B squared. That's going to be equal to 1600. That would be 40 squared. Now we just want to solve for B squared. So B squared, that's going to be equal to 1564. So B squared equals 1564, but of course we want to just solve for B. Let me see if 1564 is a perfect square, because I honestly have no idea. It's not. Alright. So, B squared is going to be equal to the square root of 1005, B would rather be equal to the square root of 1564, which does break down further into the square root of 4 times, I think, 391. Yes. Alright, so it'll break down into the square root of 4 times the square root of 391. Well, we know the square root of 4, that's 2. So B would end up equaling 2 times the square root of 391, because 391 doesn't break down any further. So the answer for side B is it would have a length of 2 times the square root of 391. So you can get some wild square roots when you're doing some of these problems. It is possible you'll get big square roots. You will see that from time to time. Alright, A equals 5. B we don't know, but C equals 8. So we have a triangle with those 3 lengths. Well, you'll still do your 5 squared plus your B squared. that'll equal your 8 squared. Alright, so 5 squared, that's 25, plus your b squared, that would equal 8 squared, which is 64. So now we want to just solve for b squared. We got to subtract 25 from both sides. If we go ahead and do that, you'll get b squared equals 39. And 39 is not a perfect square, and none of the factors of it are, so the answer for b is it would simply be the square root of 39. So side B has a length of the square root of 39. That's exactly what you would get. So that's it for Pythagorean Theorem. That should have honestly been more of a review than anything. Next lesson, we're going to talk about the distance formula. Well, there's a formula to take the distance between 2 points on the coordinate plane. So I hope everyone has a good day. Take care.